So sometimes we're trying to relate a function and its inverse, and we want to know how the slopes of a function and the inverse relate. And one of the things you got to remember is if you have a function, how do the functions relate to one another? Suppose I have some function that looks like this. This is f of x. Remember one of the things about inverses, I don't know if you guys remember this, just as a review, inverses look like they're flipped over, reflected over the line y equals x, right? So then it looks something like this. This is f inverse of x. Okay, and so the thing, if you remember finding inverses, you're kind of swapping the x and the y values. So for example, if there's some point a, point AB here, the reflected point is the point B comma A. Like you're swapping the x and the y values to find the inverse. And so we want to look at how the derivatives compare. How do the slopes of the tangent line compare? And it turns out that in this instance, the way the slopes are related is they're reciprocals of one another. When you flip the y over x, like it's sort of like the slope kind of flips also when you're swapping the x and the y. So that's what's kind of happening graphically. So the other thing I want you to think about is when you're doing the derivative of an inverse function, you're trying to find the slope of an inverse function and relate it to its original function. You're really saying the derivative at b here, the derivative of the inverse at b is equal to 1 over the derivative of the original function at the point a. So notice that there's kind of it's like there's a reciprocal, but it's also you're swapping the x and the y point. So if you're evaluating at b, that's really the y value for the original function. So you're going to plug in the x coordinate instead. Okay, so that's kind of what the formulas kind of look like, but let's kind of like see how it works in practice, right? So I want to compute the inverse derivative at a. So I'm not trying to solve for the inverse, right? Like maybe in pre-calculus you would have learned how to solve for inverses. I'm not going to try to solve for the inverses because sometimes it's not even possible. What I'm going to say is f prime at 0, for the inverse function, so I'm doing the derivative at 0, is 1 over f prime, but I need to figure out what the x coordinate is for the function. I don't want to plug in 0 here. 0 is I call the y value for this function. So how do I find this is I set this equal, this is supposed to be x squared, by the way, I'll fix that. I'm going to set this equal to 0 to find the coordinate. Like I want to know when this is equal to 0. Maybe it is x cubed. Sorry. Okay. This you could use a calculator form. You might try to factor. I think you'll find -1 works just by inspection. But when I say by inspection, I just tried -1. I would get -1 minus 2 plus 3, that equals 0. So that is the x coordinate for when the y value is 0. So then I'm going to do the derivative at -1 here. So I'm going to plug in -1 here. So now I need to compute what is f prime of x. Power rule says it's 3x squared plus 2. And then I'm going to plug in -1. And I get 3 plus 2, which is 5. So this would be 1/5. Okay? That's kind of how we handle that. All right? So let's look at the next one here. F of x equals x. So I want to do, again, the inverse derivative at 1, which is 1 over the derivative of the original function, not where 1 is, but where the y value equals 1. So I'm going to do x minus 2 over x equals 1, and I want to solve for x. I'm going to multiply through by x to make it x, to get rid of this 2 over x part. And then you get x squared minus x minus 2 is equal to 0. And this factors into x minus 2 and x plus 1. So I think this one probably needed some domain restrictions. I think I probably forgot to leave out that x is supposed to be greater than 0. Because there shouldn't be two values here. So if I'm just restricting myself to x greater than 0, then x equals 2 is what I'm looking for. So that would do 1 over f prime at 2. And so let's compute f prime of x. It's 1 plus 2 over x squared, right? Just using power rule on this guy. Okay, so just practice that. Like this is 2x to the -1, so the derivative is going to be -2x to the -2. So that's where that comes from. And so then we'll do f prime at 2. And that's 1 plus 2 over 4, right? And that's going to be 3 halves. 1.5 is 3 halves. So it's 1 over 3 halves, or that's 2/3. Okay? Same thing here. Okay, so let me clear this out and make some space for the next one here. I should have just made more space. Let's look at this third one, though. F of x is tan x plus 3x squared. Again, the inverse, the derivative at 0, is 1 over f prime. F prime is where the y is 0, so 0 equals tan x plus 3x squared. Like I said, you might have to use a calculator for this, but it turns out x equals 0 will work for this thing because tan of 0 is 0 and 3x squared, plug in 0. So in this case, you're just going to plug in 0 also, but that's just because when y was 0, x was also 0. So f prime of x, the derivative of this guy is secant squared x plus 6x. So f prime at 0. Now this is 1 over cosine squared of 0 plus 6 times 0. Cosine of 0 is 0, so that's just 1. So then just 1 over 1 is 1. Okay. Now here we're going to do this kind of similar thing. Find the equation of the tangent line at the given point. Kind of the same idea. You want the tangent line of f prime of x at this given point on this function. Maybe more clearly I should rewrite this. This is the point 8, comma 2 on this function here. So what do we want to do? Now, for the inverse function, the point is 2, comma 8. Okay? So we're going to we swap the x and the y. So it's going to be y minus 8 is m, x minus 2. And then the m is the derivative at 2 in this case, which is 1 over the derivative at 8, right? Because the corresponding point is 8 when the on the original function. So now we just need to compute what f prime of x is. This is really x minus 4 to the 1/2. So that's going to be 1/2 x minus 4 to the negative 1/2, which is 1 over 2 root 4 minus x. And then if I'm going to plug in, x minus 4. And if I'm going to plug in 8, it's going to be 1 over 2 root 4, or 1/4, right? Root 4 is 2. 2 times 2 is 4, 1/4. So this is 1 over 1/4, which is 4. So then our answer is y minus 8 is equal to 4x minus 2. And in AP Calculus, it's perfectly acceptable to leave it in slope point form and not deal with anything like that. Okay. Same thing here at x equals 2. Again, we're doing the point negative 8, comma 2. Okay. So in this case, I should have said this one should have been x equals negative 8 then. So f of negative 8 is 2. Okay. So we want to do y minus... Okay, so like we're going to swap it, right? So the point we're going to do on the inverse function is 2, comma negative 8. So this would be y minus negative 8 is m x minus 2. Okay. So what's the m? The m is the inverse, the derivative located at the x coordinate, with the swapped point, which is 1 over f prime at negative 8. Okay, so f prime of x is going to be negative 3x squared minus 1. So f prime at negative 8 is like a very, very, very big number. Negative 3 times 64 minus 1. So it's negative 129. So this is going to be negative 1 over 129. And so then our equation is y plus 8 minus negative 8 makes it y plus 8 equals the m, which is negative 1 over 129, x minus 2. Okay. Awesome. Sometimes you're just given a table, so we don't analytically find anything. So here, they want you to compute f inverse at 0. That's where, for the original function, y is 0. So f inverse of 0 is where the y value of the original function is 0, and you get the corresponding x coordinate. How about the inverse derivative at 0? Okay, that's 1 over f prime, not at 0, but when y on the original function is 0, the x coordinate there. 1 over f prime of 1. F prime of 1 is negative 3 here. So this is 1 over negative 3, which is negative 1/3. Okay. Then g inverse at 1. That's where the y value is 1. What's the x value? It's 0. And then the inverse derivative at 1 is 1 over g prime, not at 1, but at the corresponding, the x coordinate when y is 1. So g prime of 0 is 1. So this is 1 over 1, which is equal to 1. Find the equation of the tangent line to f inverse of x at the point x equals 4. So again, in this case, I think we're saying x equals 4. So we're going to do y minus, so at x equals 4, this is kind of the y coordinate for the original function. So we're doing negative 2. Y minus negative 2 is mx minus 4 in this case. Okay? Because here I'm saying, I know it wasn't super clear, but this x coordinate refers to the x coordinate of the inverse function, not the x coordinate here. So it means it's the y coordinate for the original function. And m is, again, the inverse derivative at 4, which is really 1 over the derivative, not at 4, but where y is 4, the original function is negative 3. Oh, yeah, this point I messed up. The point is not at, when y is 4, no, you see, I messed up here. When y is 4, it should be negative 2 there. Sorry, this is where I messed up. I was going to say something messed up. Inverse derivative, or derivative at negative 2, so it's 1 over f prime at negative 2 is 0. 1 over 0, this is a vertical line because the slope is undefined. So we actually don't use this. We just say x equals 4 in that case. Okay? Because when you have a 1 over 0, that means the derivative, it means it's a vertical slope. It's like, like it's a vertical tangent line. Okay, find the equation of the tangent line g inverse at the point x equals 0. So g inverse at 0, let's just find the point. So where is y 0? Oh, they didn't give it to you here on this table. Maybe this is supposed to be 1. Let's make it 1 instead, because we kind of already found something. So at 1, it's 0, right? And then so we're gonna do y minus 0 equals mx minus 1, and then m is the inverse derivative of the inverse function located at x equals 1 in this case, right? Because we're doing it at 1, which is 1 over g prime, not at 1, but at 0, right? Where the y value is 1, the x coordinate is 0. G prime of 0 is 1, so this is 1 over 1, which is 1. We already did this in number 7. So therefore, it becomes y equals x minus 1. 1 times x minus 1, which is x minus 1. Okay, so that's how you do it with tables, if you're having to do it that way. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.